Good afternoon, friends. Let's start our yesterday's paper, January 2012. The question is find out the parallel capacitance for the parallel and series plate for capacitors if there are n numbers of capacitors are connected in series or parallel. Just we go through the brief overview about the parallel and the series plate capacitor. Here the C1, C2 and C3 are the three capacitors which are connected in a parallel, where all the positive plates of all the three capacitors are connected with each other and apply to the positive supply of the battery, whereas the cathode or the negative terminal of the capacitors are connected with the negative terminal of the batteries. So this is called the parallel configuration of the capacitor. Here all the three capacitors are gets the common voltage, that is a V, or you can say that it's a total voltage, that is VT. So our VT becomes the V1 plus V2, VT equals to V1 equal to V2 equal to V3 up to, if you are connected the N plate capacitor, then VT equals to V1 equal to V2 equal to Vn. But that is not same for the capacitance or the charge which carry the capacitor, that is like a QT. So that becomes the QT equals to Q1 plus Q1 plus Q2 plus Q3 up to Qn if the n number of capacitors are connected in a parallel. So so let's start with the parallel plate capacitor. See, this is the capacitance which the capacitor carry, that C equals to Q by V, or you can write like that, Q equals to C into V, where the Q is a charge of the capacitor, V is the applied voltage and the C is a capacitance stored in a capacitor. Now the Q is the total charge, so we can see that the total charge is divided into the all three capacitors, or it is the summation of all three capacitors, so it is a Q1 plus Q2 plus Q3. So the equal voltage is become Q equals to C. We are using the first equation, so instead of writing the Q, we are putting that over there, the CV. Instead of Q1 we can write that C1V, instead of Q2 we can write C2V, and instead of Q3 we can write C3V. Here you can see that the voltage across all the capacitor is same, but the capacitance which all the capacitor carry, these are the different. Now the V from the right side and the left hand side are cancel out, so we can just get that CE, or you can say that the equal capacitance equals to C1 plus C2 plus C3. So if you are connected n number of capacitor in parallel, then your final capacitance are C1, C2, C3 up to n if the n number of capacitors are connected. So this is very important equation whenever you are finding any example or you are solving any problem, whereas if they are the parallel or the series, then this equation is very useful. So the equivalent capacitance for parallel plates are the commonly written like that, CE equals to sigma I equals to 1 to n if the n is denoted as a plate number of parallel plate capacitor. Here the three parallel plate capacitors, that's why our n is become 3, so we can write like that, CE equals to sigma I equals to 1 to 3, where n is equals to 3, and CI I equals to again 3, so C1 plus C2 plus C3. Now there is one example based on the parallel plate capacitor. Here according to the figure, all the three capacitors get the voltage 24. So 24 voltage is divided into C1, C2 and C3, where C1 is in parallel with the C2 and C3. So C2 and C3 both are in series capacitor. C1 has the 4 microfarad, C2 is 3 microfarad and C3 is 6 microfarad. So just we have to just find out the equivalent capacitance for given circuit. First of all, 3 and 6 are C of 3, 6 has the capacitance. We just find out that 3 microfarad into 6 microfarad upon 3 plus 6, these are the parallel, so the capacitance find out like that. 3 and 6 are in series, so 3 into 6 upon 3 plus 6, getting that 2 microfarad. You can just like that, C3 and C6 are in parallel, so this one is like that. Now the putting the value of C3 capacitor multiply by C6 capacitor upon C3 plus C6. So these are the series capacitor. So this one is finding like that. So that overall capacitance become that 2 microfarad. So now that 2 microfarad is replaced with the 3 and 6 microfarad capacitor which are in series. So now the circuit is become like that, whereas the 4 microfarad which has the C1 capacitance is in parallel with the 2 microfarad which are the series combination of 2 and 3, C2 and C3. Now the 4 and 2 are in parallel, so by using the equation of CE equals to sigma I equals to 1 to n Ci, where our I is equals to C1 and C2 and our n equals to 2. So the final capacitance is CE equals to 4 microfarad plus 2 microfarad is equals to 6 microfarad. Now the 6 microfarad capacitor is the total equivalent capacitance which get the 24 voltage. So you are just finding the total charge across that capacitor equals to Q equals to C into V. So by using that equation you can find Q like CE equals to 6 microfarad and V is 24. So by multiplying the 24 into 6, we are just finding the total charge into that capacitor. It's like that, Q equals to C into V. So just finding like that CE into V, where our CE equals to 6 microfarad into V, that is somehow 24 voltage. So 24 into 6, that is our total charge, and charge is measured in coulomb. The next question go through the this question is, now the finding the equivalent capacitance of the 3 capacitors which are connected in parallel with a 24 voltage of the battery. The first example is based on the 2 capacitors are in parallel. Now the next example is based on the 3 capacitors are in parallel. All the 3 capacitors get the value 2 microfarad, 4 microfarad and the 6 microfarad. Now find out the voltage. We know that in the parallel configuration the voltages in each capacitor are the same. So 24 voltage is divided into C1, into C2 and C3. This is the parallel plate capacitance equation. So capacitance becomes, all the 3 capacitors are in parallel, so we can commonly write like that, 2 microfarad plus 4 microfarad plus 6 microfarad. This becomes the 6 plus 4, 10 plus 2 equals to 12 microfarad. Note that whenever you are finding the parallel plate capacitor, the final equivalent capacitance must be greater than among the higher the capacitance value. Here the higher capacitance value is 6 microfarad, so our equivalent capacitance is must greater than 6 microfarad, and yes, it is true, that is a 12 microfarad. Now to find out the total charge across the capacitor. Charge is summation of the all the capacitance. So Q equals to Q1 plus Q2 plus Q3. Now Q1 equals to C1 into V, Q2 equals to C2 into V, and Q3 equals to C3 into V. So just finding that individually V1 equals to V2 equals to V3 equals to 24 voltage. So by using the equation C equals to Q by V, or you can write like that, Q equals to CV. So Qt equals to Ce into V, because we have to just find out the total charge of the that circuit. You can also find out the individual charge stored in the capacitor by using the equation. For example, for the CV you can find like that, Q1 equals to C1 into V. For C2 you can find like write like that, Q2 equals to C2 into V, and similarly Q3 equals to C3 into V. But here the Qt becomes the 12 microfarad, that is Ce, and the voltage, that is V, given is 24 voltage. So by multiplying 12 into 24 we are getting the Qt, that is 288 microcoulomb, because coulomb is the unit for the charge. And here is the individual charge stored in a capacitor, that is Q1. For the first capacitor C1, that is C1 into V, our C1 is 2 microfarad, so multiplying 2 microfarad with the 24 voltage, that is common for all the 3 capacitor, so we are getting 24 into 2, that is 48 microcoulomb. Now similarly Q2 equals to 4 microfarad into 24 voltage, that becomes 96 microcoulomb, and similarly Q3 equals to 6 microfarad into 24, that is 144 microcoulomb. So here if we are by taking the summation of 144 plus 96 plus 48, then you are also getting that Qt equals to 288 microcoulomb. This is the summary for parallel plate capacitor. You have to just go through some of the parameters or the equation for the parallel plate capacitor, like Ce equals to sigma I equals to 1 to n Ci, that is the equation for finding the capacitance in parallel plate. And if you want to find out the charge storage in the capacitor, then that equation you have to follow the equation Q equals to Q1 plus Q2 plus Q3 up to Qn. And if you have to find out the voltage, then voltage is common for all the capacitors are in parallel, V equals to V1 plus V2 plus V3 up to Vn. So this is the three major equation or the parameters which you have to mention in a parallel plate capacitor. Now if the capacitors are connected in series form, the series connection is such like that the first plate of the capacitor is connected with the second plate of the next capacitor. So you can say that the positive and the negative plate of first capacitor, so the negative plate of the first capacitor is connected with the positive plate of the second capacitor. Similarly the negative plate of the second capacitor is connected with the positive plate of the third capacitor, and the sequence is follows such like that. See the figure where the negative plate of the C1 is connected with the positive plate of the C2, and negative plate of the C2 is connected with the positive plate of the C3, and first positive plate of C1 is connected with the battery, and the last negative plate of the capacitor is connected with the battery. So this configuration is known as a series configuration of the capacitor. If you are connecting the n number of capacitor, then this sequence is continuously followed. Now the charge storage in capacitor for the series plate, we are just go through the parallel plate where the charge is Q equals to summation of Q1 plus Q2 plus Q3. Now this one is finding in parallel series plate capacitor. Here the charge across all the capacitor is same, but the voltage is different. See here, whatever the voltage induced in a parallel plate, that becomes the charge induced in a series configuration. So our Qt equals to Q1 equal to Q2 equal to Q3. So if you are connecting the n number of capacitors in series form, then your charge become Qt equals to, or you can write like that, Qe equals to Q1 equal to Q2 equal to Q3 equal to Qn. Now the voltage in a series configuration, as we all know that voltages are different in series configuration, but the current is same in series configuration. Where if you have to talk about the parallel plate, then the voltages are same in a parallel plate, but the current is different in a parallel plate. So here the three capacitors C1, C2 and C3, and all the voltages generated in C1, C2 and C3 are denoted as V1, V2, V3 respectively. So the voltages are different. Vt equals to V1 plus V2 plus V3. This is the equivalent capacitance in series form. C equals to Q by V. This is our common equation. So we have to just find out the voltage. Then we can write like that: V equals to Q by C, where Vt equals to Qt by Ct. If we are talking about the total capacitance or total voltage with respect to total charge. So now C equals to, by using that equation, 1 by instead of writing V equals to 1 by C equals to V1 equals to 1 by C1, V2 equals to 1 by C2, and V3 equals to 1 by C3. So putting the value over there, our Q is cancel out. So we just finding that final total equation is like that: CE equals to 1 by CE sigma I to N C1, C2, C3 divided by C1 plus C2 plus C3. This is the common equation if you are finding the series plate capacitor. See, you can see seen here like that: 1 by CE is our equivalent capacitance, equals to sigma I to N. N is the total number of capacitors connected in series, 1 by CI. See, here one example is given: C1, C2 and C3 are connected in series form. So C1 has the value 0.1 microfarad, C2 is the 0.2 microfarad, and C3 is 0.3 microfarad. So we have to just find out the total number of capacitance, Q1, Q2 and Q3. The capacitance charge in the three capacitors are same, so whatever the Q1 becomes equal to Q2 equal to Q3. But the voltages in VC1 or VC2 or VC3, these are the different. Here you can see that 1 by Ct, the total charge capacitance is 1 by Ct equals to 1 by C1. C1 is 0.1 microfarad plus 1 by C2, that is 0.2 microfarad, plus 1 by C3, that is 0.3 microfarad. This become 1 by 18.33 into 10 raised to minus 6. So we can, by using the mathematical solution, we can find like that our total charge capacitance is C equals to 55 nanofarad or 0.055 microfarad. Go through one video for the series capacitors.
Over how to calculate the charge, the voltage, and the equivalent capacitance for series that for capacitors that are in series. This is the circuit we're going to use for this video. We have a 12 farad capacitor, a 6 farad capacitor, and a 3 farad capacitor, and we have a 6